Yeah, that sounds really good.
Yeah.
Okay, the next study guide is cross connection and backflow prevention. It's a big boy. So, let's go to question number 1. Question number 1, vacuum breakers and reduced pressure zone backflow preventers should be installed in an accessible location, blank, how high above grade, so they can drain properly and the dump will never be submerged.
That would be 6 to 12 inches on it, minimal.
There are, so what we're talking, so the vacuum breakers and reduced pressure backflow preventers, there are some that are 6 to 12 inches, but reduced pressure zone backflow these are 12 to 18 inches. 12 to 18 inches. And this is a question that's very, you found in a lot of the study material for backflow prevention certification for repairs and for testing. And so the key here is that reduced pressure zone backflow, the RPZ, 12 to 18 inches. We want that dump to be able to dump water without being submerged. We don't want them, we have to be extra careful that these don't get submerged. Number 2, anytime a potable water supply comes in contact with waters of a questionable quality, what do we call that?
That'll be a cross connection on that one.
That's a cross connection, C. So anytime, and there was once that I went to a wastewater treatment plant and they had a fire hose next to the headworks. And they had been using the fire hose to spray everything down. Well, they shut down the valve and they put the end of the fire hose was laying over the edge into the headworks.
Oh.
Now the level was several feet below that, but still it's a good example of what you don't want to do. It's a good example that somewhere, someday, somebody, not knowing any better, might lay a hose into a basin, and anytime it's not in our distribution system, then it's questionable quality. So you have to be very clear on that. Anytime it's not, if the water is still in our distribution system, we have control of it, we understand what the quality is of it. Once it leaves, once it goes into a basin, it's no longer, we don't consider it safe or potable.
Yeah.
Number 3, the best way to protect the water supply from contamination by cross connection is?
I'm gonna say C, an air gap.
Air gap. Air gap is the best way. And one of the best examples of an air gap is your bathroom faucet and sink. You should be able to plug up the drain in your bathroom sink, turn on the faucet, and if it fills up all the way, it still won't submerge the faucet, the water coming out. The air gap is going to be a minimum of twice the diameter of the pipe that's feeding it, or the opening in the faucet. So let's say it's 1/2 inch. It's going to be at least 1 inch above the water line. So it'll never get submerged. That's an air gap. An air gap will not allow water to feed back into a faucet, in this case.
A water supply.
A water supply, yeah. So always, air gap is always the best way. Number 4, the primary purpose of check valves is to prevent
The water from flowing in 2 directions.
exactly the check valve. And the thing about valves is they're named in accordance with their closure element. That's the thing that closes, right? So if it's a gate valve, you have a gate. If it's a check valve, you have a check. If it's a plug valve, the closure element is a plug. So the check valves, what they do is they allow water to flow in one direction. If the water reverses, the check closes. The check closes and restrains the water from flowing backwards. They're not the best way to prevent backflow, but they're a good way of preventing the water from flowing backwards. Number 5, an enclosed space or area with less than atmospheric pressure is considered?
Less than atmospheric pressure would have to be B, a vacuum.
Very good. Number 6, the reversal of the flow of water back into the distribution system caused by a difference in water pressure. That's not on there. Caused by a difference in water pressure. So the reversal flow of water back into the distribution system caused by a difference in water pressure. What would that be? I gotta change that.
Would that be C then?
Back
Is
pressure.
that pressure, yeah.
Absolutely. So if we had the utility side here and the customer side here, the customer or the user, if pressure for whatever reason on the customer side is greater than what's on the utility side, then the water will be forced back through the distribution system. It's going to flow backwards until it can't. So somewhere, now this would be generally at some type of commercial site or industrial site where they're producing chemicals or something that maybe they need high pressure water. So they're getting their water from the utility and somehow, and they're running it through some kind of equipment that pressurizes the water so they can use it at a higher pressure. If that pressure somehow feeds back into the utility, the water's gonna flow backwards. How do we prevent that from happening? How do we protect the distribution system? An RP, reduced pressure zone backflow preventer, is a really great way of doing that. So in this case, number 6 is back pressure C. Number 7, the separation and air gap must be
Oh, you already said this. This is D.
D, twice the diameter of the pipe. I find that if we hit it 2, 3, 4 times, even in other lectures, you'll hear me talk about that because it needs to land home with you. You know, for just about any test you take, depending on the discipline, you're going to run into a question about air gaps and several other subjects.
Yeah.
Number 8, this is caused by negative pressure developing in the water supply piping.
That'll be back siphonage then.
Back siphonage. So again, we have the utility side, we have the customer side. In the middle, we probably have some type of backflow device like an RP. But what if on the utility side, there's a line break? Somebody's out there digging a trench, they didn't have a blue stake or they didn't care, and they dug right through that main line. What if it's a 32-inch main, water main? They pop it, water wants to go to the path of least resistance, it follows gravity, so water starts pulling back. You remember, these water mains are full. So as soon as you shut that off and or if you break it and water starts to drain out, you might have miles and miles of full pipes of water. As soon as you get a break, that water wants to empty out. So it's gonna spill back as long as gravity takes it there. And as that's happening, it's creating upstream, as water leaves, it's pulling the rest of the water with it. It's creating a vacuum. So if the RP is protecting the distribution system, it's gonna stop the water flowing out of the customer side, right? But one thing that we have to consider is that within the pipe, as water is being pulled back, there's no atmosphere in there. It can create a vacuum, and we know what happens with a vacuum, right? It can crush that pipe like a submarine.
Yeah.
Right? So we have to have these devices called air release valves or combo air release valves. And what they do is they act as the lung for pipe. If this is a main that has on-off, right? It fills up with water, it's under pressure, and then at some point it shuts off and the pipe starts to empty. So once the water is pushed down that pipe, any air that's trapped inside the pipe has to escape. It's going to escape through an air release valve. A combo air release valve will allow that when the pumps are turned off, when the pipe is emptying of water, it's going to let air in so it doesn't create a vacuum and crush the pipe. Number 9, the best way to prevent backflow is to,
I believe it's C, install a check valve.
the best way to prevent backflow is to permanently eliminate the hazard. That was a good guess. Permanently eliminate the hazard. And the best way to permanently eliminate the hazard is to install an air gap. A check valve is on the list. Making it illegal, we have regulations in place.
Yeah.
You know. Number 10, I was looking at the wrong number. Of the choices listed below, this device is not approved for use at service connections.
Now, is that service connection on the customer's house?
Yes,
Or?
it's a service connection.
Okay. You would want reduced pressures. You would, well, air gap separation, you don't want that hanging out in the yard now, do you?
Well, it depends on the service connection, which customer it is.
So then it'll be double check. Or would you want that still?
Well, C is a pressure vacuum breaker,
Mm-hmm.
and that would be the one that you would
That would
want
be on-
at a service connection.
Because you want that on our side, right?
Yeah.
Yeah, okay.
Yeah. Well, and they could be used on the customer side too, for protecting their equipment or whatever.
Yeah.
But we don't want it at a service connection.
No.
We'd rather have an air gap.
Yeah.
But if the customer needs the pressure that arrives with the water, you want a RP. Double check valve is not really the best.
Not ideal.
Okay, number 11. This occurs when the user's water supply is at a higher pressure than the public water supply system.
Back pressure.
Back pressure.
Time out.
So, number 12. Who is responsible for preventing contamination of the public water system by backflow?
Would that be responsible for preventing contaminating of public water? So that'd be the water supplier.
The water supplier. The water supplier is the utility.
Mm-hmm.
Number 13. Who is responsible for keeping contaminants out of the potable water system on the user's premises?
On their premises will be the customer.
That would be the customer or the user. Very good. Number 14, who is responsible for preventing the creation of cross connections through modifications of the plumbing system on the user's premises?
If it's on the user's premises, that would still be the consumer, the user.
The customer, the user. So this is one of the reasons why plumbing code exists. It's one of the reasons why we, as a utility, have our own regulations, requirements, details. You know, whenever somebody's building a new development or a new business, they contact us and they get our details, they get our requirements. How do they have to build it? Right. So now if a licensed contractor is going out to some business down the road here that's already been there for 15 years doing some type of repair that involves new piping, they're going to build it to a certain code. That's what's expected. You know, in some cases they're going to have an inspector come in from the city or the county, even the water utility. Not so much us. We don't do that type of inspections, but you know, in some cases, in some cities, it might be a municipal inspector, might be a county inspector. There are certain codes that they have to go by. And that one main reason is to protect the water, the public water supply.
Yeah.
So, 15, these devices must be tested every year by licensed and certified technicians. We have air gap separation, reduced pressure principle or an RP device, pressure vacuum breaker, double check valve.
I mean, I'm thinking all of them.
All of them. Yeah.
Everything has to be, yeah, at least once a year, right?
Yep.
Yep.
Once a year. And we have a program in this utility, we have a requirement that everybody with a device, some type of backflow device that we've required them to install, it's got to be recertified every year.
Yeah.
Number 16, when 2 checks fail, what is the pressure between the checks?
If they both fail?
If they both fail,
That'd be 0.00, because they'll be equaled out, right? If they both failed. Now,
so this is an interesting question, and I talked to some Backflow certified, a company that does Backflow certification. So it's the thing about both checks. If this device fails, it should be dumping water because utility pressure is pushing at it. And so to protect the public side, if one check fails, it's going to dump water. If both of them fail, you could be facing utility water pressure between the 2 checks.
so whatever the utility itself is providing, that's what you got.
That's the water pressure you're going to get because ideally this thing's dumping water.
Yeah.
And that's one of the indications that it's failed or that there's a problem with it. It's dumping water out of the dump located at the bottom of these twin checks. Okay. All right.
Sweet.